Hey everyone, welcome back to Code Streak Daily. In today's video, we are going to solve the Leetcode daily problem. So here we have a problem: separate black and white balls. So it's a medium level difficulty problem. Let me read out the description. There are n balls on a table. Each ball has a color black or white. So you are given a zero index binary string s of length n, where 1 and 0 represent black and white balls respectively. Okay, so that means 1 represents black ball and 0 represents white ball. In each step you can choose to adjacent balls and swap them. Return the minimum number of steps to group all the black balls to the right and all the white balls to the left. So we have to put all the white balls to the left and all the white black balls to the right. That means our string must start with 0 and end with 1. That's the basic idea. So here we have a string 101 and the output will be 1. So let's see the explanation. We can group all the black balls to the right in the following ways. Swap s of 0 and swap s1 is equals to 0, 1, 1. So initially ones are not grouped together, requiring at least one step to group them to the right. As I said, our string starts with 0 and ends with 1. Okay, this is how in the same manner we are doing this. And if already the strings are swapped, I mean if the balls are in arranged, that is all the zeros are to the left and all the ones are to the right, sorry, that means we have to return the 0. Okay, so uh, there are no constraints here. This is a basic constraint, that's it. So we have to write a Python solution to solve this efficiently in a linear time. By the end of this video you'll understand how to calculate the minimum number of swaps to that are required to group these balls. All right, let's break it down now. You are given a binary string where ones are blacks and zeros are white balls. In each step we have to swap to adjacent balls, right? Now let's see the approach here. Let me reset the code. That's it. So here we have a class solution and there is a function in it, minimum steps. Here we have a string s and we have to return the integer value. Okay, first we need to know where the black balls are located. We have to create an empty list to store the indices of all the ones in the string. So okay, I'm taking like a ones position with a empty list. So to store the indices of all the ones that are black balls. Okay, now we have to loop through the string. I'm using the enumerate, Python's enumerate, to get both the index and the character at each position. Each time we encounter a one, we store its index in the ones position list. This helps us to track where the black balls are currently located. Okay, so I'm taking a for loop for I as well as char in enumerate of s, our string, right? String s. What we are doing? If char is 1, in that case what we are doing? One's position dot append of I. We are just appending the index value. Okay, that's it. And next will initialize two variables, minimum steps and where we will store the total number of swaps required, and total ones is just the count of how many ones we have in the string. So this will help us calculate the target positions for the black balls. Okay, so now I'm taking minimum steps equals to 0 and total ones equals to length of one's position. Okay, now here's where we calculate the minimum number of swaps required. For each one we will calculate the target position where it should ideally be placed if all the black balls are grouped together on the right. Okay, here we will use the formula length of s minus total ones plus I, where I represents the position of the one in our list of ones positions. Then we'll calculate how many swaps are needed by subtracting the current position of the one from its target position, and we'll add this difference to the minimum steps. Okay, so for I and position in enumerate of what? Enumerate of one's position. Enumerate of one's position. What we are doing here? target position equals to length of s minus total ones plus I. Okay, we will get the target position for 1. Next, minimum steps, we have to add it, right? Minimum steps equal to target position minus POS. Okay, now what we have to do? We have to return the minimum steps. That's it. Okay, we will return the minimum steps, and now let's see what happens if I run the code. Okay, here we have all the test cases passed. Let me submit the code and check if all the hidden test cases will pass or not. As you can see here, all the test cases have been passed and we have a runtime of 113 milliseconds, and it beats only 38.21% of users. Okay, that's a very low number for me. So it's okay. We'll do in very great manner in the next video. Okay, so that's it for today, guys, and this is how we have solved the problem. And if you have any questions or if you want me to discuss any more topics, please do let me know in the comments. I'll surely check on that. And if you do have efficient code than this, please do put that in the comment. I'll surely check on that. So we'll make a more efficient code in the next coming videos. Okay, so if you found this video helpful, please do subscribe to CodeStick Daily, hit the bell icon, and also do like and share the video. So happy coding, guys.